Tears contain lysozyme. Let's fade back again to what we know about tears. Point to your lacrimal glands. Okay, are they here? No, they're here, right? You were close, you were close. So they're embedded up underneath the bone in this particular region. They secrete tears, which are salty. At the same time, they also contain lysozyme, an enzyme. What does that do? It floods down over the surface of the eye, which is a great port of entry, isn't it, when you think about it? Very delicate tissue, open all the time. We get impinged with all kinds of stuff. Dust, fungi, bacteria, viruses, protozoans, all kinds of stuff gets stuck on our eyes, and it immediately gets washed off or killed outright by the liquid form and the lysozyme dissolved in it, and the salts dissolved in it. And what does it do? It drains down to the puncta, and we've got, what, a drain that runs through the lacrimal bone down into the nasal cavity. And if anything gets sucked up our nose, we try to kill it off and, with those same type of enzymes and salty material as well. So we've got mucus. Mucus does what? Well, be a little more specific. If you stick your finger up your nose right now, get it up there pretty far, and kind of roll it around with it, pull it back out again, and roll your fingers together, what do you notice about that mucus? It's sticky. It's sticky. So how does it function? It's really almost like a physical barrier, because what does it do? It allows things to get impinged. And what happens with that? Either it forms a booger and falls out, right? Or it rolls back and into your throat and you swallow it. And it goes into the acids of the stomach, and we kill off those little guys that got sucked up your nose or on your eyes. So does that intact skin make sense, right? As long as your skin is intact, we don't have portals of entry, bugs can't get in. And one of the things we have to talk about here is that Staphylococcus aureus, that bacterium you've all heard about over and over and over again. And usually when you think Staphylococcus aureus, you think what? What infection? Yeah, staph infection, the one that gets the most headline is, okay, or we'll call it MRSA. Nursing talk is MRSA, which is okay. I don't like it. So it's methicillin-resistant Staphylococcus aureus. So we hear about that. But Staphylococcus, everybody's got it all over your skin. You've got it up your nose. It's commonly found in those regions. It plays a very important role because Staphylococcus aureus found on your skin, not causing disease, as long as the skin stays intact, produces a variety of acid kind of excretions that keep loads of other bacteria and fungi from colonizing your skin. It plays a very important role. What happens, though, is that we get a break in the skin, and staph kind of falls into that, Staphylococcus aureus, and it goes, well, I've never been here before, and things are nice here. They're nicer than they were on the surface of the skin, and it starts to set up a localized infection. So with keeping that skin intact, we don't have a problem. Cilia in your throat, and what does cilia do? We'll talk about that with the respiratory system, but they have the ciliary escalator, so that stuff that you inhale gets caught on the mucus found in your trachea and your bronchioles, and we move it back up again to your throat to swallow it. Got earwax. We talked about earwax last semester and last quarter. And what do we say? If you get caught picking your ear, and then you clean your teeth and you kind of go, ugh. That wax, that ceruminous wax that's found in the ear is strongly antibacterial because it's nice and warm and it's moist in there. So it's a first line of defense, and it happens all the time. We're constantly bombarded with these potential pathogens that we would call what? Antigens, antigenic agents, another name for those as well. But what happens if they do make it through? So the first line of defense didn't hold. Now, whether that's because you you had a hangnail and you bit it, you ripped it back, and you went, oh, and all of a sudden now, at the end of the day, it gets kind of hot, puffy, and you go, what's going on here? Well, you've set up a localized infection, and we try to set up then a second line of defense. And who gets involved here? Well, we know that damaged cells do what? Cells that are damaged, they've been either physically or chemically damaged, they will do what? They start to dump stuff, correct? Their membranes are ripped open, they start to dump stuff, and some of those things that they dump are cytokines. Cytokines are these cellular hormones. And there are a whole variety of them, but many of these cytokines have the capability for causing vasodilation. And there are some other cells there that may not have been damaged, but are kind of hanging around going, whoa, these cytokines released from that cell are going to also increase the vasodilation, and I'm going to start to dump out something like histamine. So when cells do that, so we get this localized fever. Your finger feels hot, it's red and it's swollen. All of that's kind of going on. And then we have these phagocytes begin to show up. And we'll talk about what those are in just a second. And we've got something called interferon, whatever the heck that is, that may be involved as well. So we start to see chemicals being dumped in all of this. Take a look at the handout I just gave to you before, the one that's got this list. And again, as you work your way down through this, you're going to recognize most of the names of the cells that are on there. Some of the cells down below have different names, different people refer to them by different names, and it gets a little bit confusing. But if we take a look at the top where it says non-specific immunity, everybody with me? And you look down there on neutrophils and monocytes and macrophages and basophils and mast cells and eosinophils. These are all in one way or another involved with this non-specific type of immunity. Now let's just walk through these quickly. So what do neutrophils do? We know that they're phagocytic. So where have they been prior to this infection? Because they showed up here after we ripped the skin open, and we've got some bacteria in here that are causing a bit of a problem, and we got dead cells that we need to clean up and get out of here. Where were those cells prior to this time? Yes, exactly. Say that, Marco. That's great. And so they have this capability of what's called diaphoresis. We use the terms we should have used before, which means that these cells can do what? Creep out through capillaries, leave capillaries, they squeeze through those endothelial cells that form the capillaries, they get out into the tissues, and they're going to that site. How do they know where to go? Cytokines. Because there are these signals from the damaged cell that say, we've got a problem here. And it's like a pheromone. It's like a perfume that's out there. And we start to then make our way in to where those concentrations are greatest. We know that's where the problems lie. And so what do they do when they get there? What do neutrophils do? They gobble up what they can. They'll take your old, dead, broken cells, they'll clean those up, they'll try to find them, if it's bacteria, fungi, whatever it happens to be, they'll try to eat that stuff up, and in most cases they do a pretty darn good job. Monocytes, we alluded to those very briefly yesterday. Those are also typically found in the circulatory system, and they turn out to be what are referred to as macrophages. And simply means to differentiate them from neutrophils, which are smaller and sometimes called microphages. Macrophages are simply larger. And they'll